Again. I'm here to help you with this question here on an example from medicine and cancer. So on this question, we are again going to be using a conversion with proportions. So just get your equation kind of set up. Remember, we want what the question is asking for in the upper left corner and what the question is giving to you in the lower left corner. And then on the right side of that equal sign, we usually use things from the periodic table or the idea that 1 mole is 6.02 times 10 to the 23rd. So on this one, we'll look at what does the question want. So kind of scanning through, common chemotherapy chemical, is that thing right there. One tumor cell is killed by 1 million of those molecules in the picture above. Oh, here's my question words. How many grams should be given to the patient? So that is going to be my X. And again, I'm going to put in parentheses, what units do I have? So what we're looking for is how many grams? Well, how many grams of what? Grams of our molecule. So we first need to know something about our molecule for the given. So we look at this and it says, okay, one tumor cell is killed by 1 million of these molecules. And in my picture here, I kind of have to look at that. These bluish colored ones are the tumor cells. So first I have to actually count how many tumor cells do I have. So just kind of go through and count. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I have 22 tumor cells. Well, 22 times a million means I have 22 million molecules is what I need. 22 million molecules. Okay, so what we have to do is we got to figure out how are grams and molecules related to each other. So we look, and again, like I've said before, grams needs you to use the periodic table. So to figure out grams on the top, we're going to have molecules on the bottom, but grams are going to be on the top. We need to go back to the periodic table and we need to look at the chemical formula and figure out how much it weighs. And this is a big one. So we have carbon, but we have 15 of those. So I look at my periodic table. Carbon is 12.01, but I have 15, so I have to multiply that by 15. I have hydrogen next. Hydrogen on the periodic table is 1.01, but there are 22 of those. So multiply that by 22. And then F is fluorine. So again, looking at the periodic table at fluorine. Fluorine on your periodic table is 19.00, but there's only one of those. And then we have N for nitrogen. Nitrogen on the periodic table is 14.01, and our equation says we have 3 of those. That's subscript 3, so I'm going to multiply this by 3. And then we have O for oxygen. Oxygen is 16.00, and our equation says we have 6 of those. So now you pull out your calculator. You're going to have a big old question here. So 12.01 times 15 plus, and this one might be easier to use parentheses around things. You got to do all the multiplying first, remember, for order of operations. Okay. Plus my fluorine plus my nitrogen plus my oxygen. And I'm going to have to double check this real quick, but right now I'm getting 359.40 grams. I'm just going to go back, double check, make sure I typed everything in right. So I got my carbons. So I'm just going to write that out, 180.15. This is going to be 22.22 plus 19. This is 42.03, and that's going to be 96. Add them all together. 359.40 grams. Now again, where does this number go? This goes with grams on the top side of the fraction. So now what we're saying is, okay, this is how much we would have if we had 1 mole of this chemical. Okay, so if we have 1 mole, it would weigh 359.40 grams. But this question is not asking us for moles, or it doesn't give us moles, it's giving us molecules. Molecules is that object. So we have to remember, what does 1 mole mean? 1 mole means 6.02 times 10 to the 23rd molecules. Now I have my equation. Now I need to solve it. So, okay, I'm going to multiply everything out. Make sure you don't mess up on the zeros here. And this is what I got for my answer. 1.31 times 10 to the negative 14. Let's see, the 3, 6, 7, 8. Now, why does that number make sense? This is going to be grams. Why is it a negative power of 10? Well, compare these two numbers here. 22 million is a big number, but not compared to 6.02 times 10 to the 23rd, which means our answer on this side is also going to be really tiny compared to 359.41. Okay, it's just a ratio. 359.41 divided by 6.02 times 10 to the 23rd. If you did that on your calculator, you get a number. If you took 1.31 times 10 to the negative 14 and you divided it by 22 million, you would end up getting the exact same number. That's why a proportion works. It's just trying to say, hey, we're going to take this number, which we know to be true, and we're going to scale it way down to this number. Well, if we do that, what is this number scaled down equal to? Well, turns out 1.31 times 10 to the negative 14.